This is Danica McKellar. Let me change the screen. Hello. All right, let's get this set up, the camera. So my name is Danica McKellar. I am an actress and a math book author, math lover in general, a mom, and I periscope about a lot of different kinds of things. Hang on. Today I'm going to periscope a proof of the fact that the square root of 2 is irrational. I'm trying to get this camera to angle down. Hang on. Let's do this and bend it. There we go. Great. So, all right. So I've written this. The square root of 2 is not equal to p over q. What does that mean? For some reason, we use integers, which are the whole numbers, negative and positive. We usually use p and q to represent those. I'm not really sure why. That's just a standard. So in order to prove something like the square root of 2 isn't irrational, first I'm going to briefly describe what it means to be irrational. Well, first of all, what does it mean to be a rational number? A rational number is a number that can be expressed as p over q. So any rational number, what it means is that you can be expressed as a fraction of two whole numbers. So 1 million over 365 billion is a rational number. The square root of 2, well, let's see, pi is an irrational number. Let's see. Oh, so in decimal form, if a number has a repeating pattern, like say 0.12121212, that actually can be expressed, even though it's infinite, that can be expressed as a fraction. It can be expressed as one whole number over another. I believe it's 12 over 99 if you do that. However, there are other predictable patterns for decimals that are not rational. For example, 0.1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. If you keep doing that, that's a predictable pattern, but it's not rational because it cannot be expressed as p over q. So that is rational versus irrational. Now, the way we're going to prove this is actually called a proof by contradiction, which means I'm going to say, well, what if we could write the square root of 2 as p over q, where p and q are integers? Could we take that information and then lead ourselves inexorably to a false statement or some sort of contradiction? And if we can do that, then we've proven that the thing we started with could not have been true in the first place. So let's do that. Let's say, well, okay. Let's say, wait, what's a good color? This is my son's chalkboard with all different kinds of colors and things. What if the square root of 2 could be expressed as p over q, where p and q are both, we can say positive numbers because this is a positive number. So either these could both be negative or they could both be positive. So we'll say, well, we're going to do the expression that's the positive version, and we're going to do the expression where p and q are mutually prime. What does that mean? It means that any fraction can be reduced to its simplest terms, right? So let's say you had 4/6. Well, we know we can write that as 2/3. We know that. So since we know that, we are now going to boldly say that we've written the square root of 2, since we can do this, we've written the square root of 2 as p over q, where p and q are both positive and they are mutually, they are relatively prime. So they do not have any factors in common. There's no way to reduce this fraction anymore. There's no way to reduce this fraction. Keep that in mind. Okay, so now that we're assuming that we can write the square root of 2 as p over q, well, let's mess around with this in very legal ways and see if we end up with a contradiction, which is what we want to have happen. So let's square both sides, because who wants to deal with that square root? This is going to be 2. And remember, everything was positive, so there's no issue here. And this becomes p squared over q squared. And there's already a problem. The problem is that if this equals 2, then how do you get a fraction to equal a whole number? That means that we were able to cancel off factors. That means that, let's say p is made up of like p1, p2, I don't know, let's just say there are 3 factors just to keep it simple. p1 times p2 times p3, and this was q1, Q2, well, it doesn't matter how many, say QM. And then squared means that these things happen again, so it's just the same ones again. Then they'd have to cancel out. We'd have to be able to cancel out all these factors and be left with just a 2. Let's say this one was the 2. Well, if that's the case, then that means that P and Q had factors in common. So if P and Q have factors in common, that means that P squared and Q squared have to have factors in common, and reverse. The inverse of that is also true. So since this cannot be true unless if P and Q had factors in common, that means that we've reached a contradiction. So this is the proof that the square root of 2 is irrational. You guys had been asking for math proofs. I hope you liked this one. It's kind of cool as long as you are really comfortable. You can hardly see the colored chalk. Yeah, okay, let's see. What's it? I have... That's better. Hang on. I'll go over what I just did. The square root... No, I'll just rewrite it. Okay. Recapping for those just... Well, dry erase boards, you know, they're so smelly and messy and stuff, but I'll think about dry erase boards. Oh yeah, the reason why I did the hashtag birthday is to get balloons, by the way. So some of you might notice that there are balloons in the heart stream, and I didn't do it just randomly. Today is my 4-week birthday on Periscope. So let's go over this proof one more time. Light reflection in board. Yeah. Yeah, you know, these are not professional videos, guys. This is like me running downstairs and doing this. So here we go again. So we are proving that the square root of 2 is not equal to P over Q, meaning where P and Q are integers, meaning that the square root of 2 is irrational. So here we go. Let's say that the square root of 2 could be equal to P over Q. And if that's the case, then P over Q can always be written in reduced form, and they're both positive, because, well, we can choose to use the positive form. Either they're both negative or both positive, because this is a positive value. So we're going to say P and Q are both positive, and they have no common factors. So this is a completely reduced fraction. No common factors. If they did have common factors, we would just cross them off and say this is our new P and Q. That, yeah, the chalk is way better. Sorry, guys, about that. So this is the reduced form. Now, we are taking this bold statement of ours and saying, if this is true, can I lead ourselves to a conclusion that tells us that something very false? So we knew that this had to be false. Let's do it. Let's do some things to this. We'll square both sides. What is the square root of 2 squared? It's just the thing that was inside the square root symbol, which is 2. And this equals the 2 distributes to both the P and the Q. And these exponent rules are in, I think, in Hot X, Algebra Exposed, my algebra book, if you guys want to brush up on that kind of thing. Also, square roots are covered in the algebra book as well. P squared over Q squared. So we took this statement and we got to this statement. This follows from this statement. But this is already our contradiction. This can't possibly be true if this were written in reduced form. Because how would you get to a 2 from a fraction? That means that there are factors that canceled each other out, and we ended up with 2. We ended up with nothing on the bottom, so all the Q factors are gone. They were all also existing in the top part of the fraction. And that can't be the case, because if P and Q were mutually prime, meaning relatively prime, meaning they had no common factors, the same would have to be true with P squared and Q squared, because no new factors are introduced. They're just more of them, more of the same ones. So that is the proof that the square root of 2 is irrational. And that's kind of amazing when you think about it. We now know that the square root of 2 cannot be written as a fraction, which means it cannot have a repeating pattern. Even though we can't see how many digits are there, we know that even if there were a million, those million digits couldn't repeat themselves again and again, or a billion, or as big a number as you can possibly imagine. That section cannot repeat again and again, because if it could, then it would be a rational number, and we've proven this. Something I love about math is that you can prove things without having to touch on to all the complications that would lead you to understanding that. So anyway, this is the proof that the square root of 2 cannot be written as a fraction, meaning the square root of 2 is irrational. So that is my proof for today. You guys have all been asking for it. And let's see, yesterday I periscoped. I did some behind the scenes stuff with PBS, and I think that stuff, yeah, it's still up. It'll still be up until this afternoon. And then last night I periscoped with my friend Elizabeth Keene, who has the blog akeensenseofstyle.com, Keene with an extra E at the end. And she's awesome and amazing. I'm trying to get her onto Periscope. She might be watching this right now, I'm not sure. And she's great, and I introduced her to Periscope in a Periscope last night. And oh yeah, ask Siri what 0 divided by 0 is. She talks about cookies and friends, and Cookie Monster is sad or something. It's cute. Yeah, my stepson did that for me. I try to tutor my friends' kids, and the problem is that they know me, and so it's like, yeah, whatever. But I really do love math, and I love teaching math and helping people with math. And again, the concepts that you needed to understand to do this are pretty much, yeah. That stuff is covered in Hot X. I don't do this proof. I don't do this proof in this book, but I talk about exponents and square roots in this book. This is the Algebra 1 book for kids in high school algebra. So that is it for now. I hope you guys are great. Tomorrow, I plan on doing a Periscope. I'm going to call it Periscope 101, and I'm going to talk about the basics of Periscope that I've learned in the last 4 weeks for watching Periscopes and for making Periscopes. And I'm going to try to make it pretty concise, so I hope you guys enjoy it. And by the way, speaking of Periscope experiences, when my Christmas movie comes out, it's called Crown for Christmas, it comes out Friday, November 27th, I'm going to be live tweeting and live periscoping. I'm pretty sure I'm going to be live tweeting the entire time for both the East Coast and the West Coast premieres, and then I'll only be able to periscope during the West Coast premieres because that's when I can see the movie because I'm on the West Coast. If I could think of another way to do it, I will. But I look forward to interacting with you guys live during the movie. I think it's going to be a lot of fun. I'll probably periscope during all the commercial breaks for the movie. That's what I'm thinking. And then I'll be able to answer questions and tell you guys behind the scenes trivia and stuff like that. So thank you for everyone. I didn't thank people today for sharing. I'm sorry. I wanted to jump right into the proof, but thank you so much to everybody who shares. And thank you for all the hearts. And thank you for all your support. And I will do more of a Q&A next time around. You would think that it wouldn't have calls come in when you're periscoping, but it does. So that's all the time I have for it today, but I really, I love all you guys so much. Thank you so much for watching, and I'll see you tomorrow for Periscope 101.